good enough size.
Probably a little bigger, I think.
Alright. Cool. Yeah, so today I'll be giving a talk about generics. And my name is Jacob Sakati. I've been a developer for about 9 years. I've been developing with Golang for the last, I'll say 3. And we had a discussion, I think in August, where some people were mentioning what are the use cases for generics, how we use them, what do they mean, right? So I'll just be giving a pretty simple talk on what generics are, and I'll be introducing some concepts within generics, within Golang itself, and yeah, how to use them. So pretty much a generic is any programming concept that allows algorithmic functions and procedures and data structures that is designed to work with many types of for the same parameters, right? So let's take a instance here, just plus operator. So a simple plus operator, right? We have x plus y. Or we can have like, string 1 and string 2, we can concatenate them together, right? Or maybe we can do that same thing with some floating point numbers. But if we create a function, let's call it add, the problem becomes that add only takes in integers, right? So we're not using generics in this function for add. So when we use add, we can only take in integers, 5 or 8. But we aren't allowed to take in 5.59 or 8.9 or floats or strings or anything like that, right? And that's where generics come into use. So let me run the debugger here so we can follow along. I believe it starts with using add. Yeah. Okay. It does plus operator. Yeah. We'll just start right there. Output. Yeah, debug console. Drag that down a little bit. Okay, cool. Yeah. So we know that using the plus operator, yeah, this is just going to give us 3, string 1, string 2 concatenated, right? And then 3.1 as a floating point. Now, when using add, we can only add integers together. We can't add the floats or strings, right? Because add function is just for ints. So 5 plus 8, equals 13, right? So we get 13. Pretty cool. We all know that. Now let's move on to generics. So for generics, when we want to add something together, Golang gave us the opportunity for comp ordered. And what comp ordered is, it's pretty much anything that accepts and supports lesser than equal, greater than equal, and greater than operators, as well as plus minus operators as well. It will not support any multiplication, division, or mod, or bitwise operators. But as long as the type T is comp ordered, which is any underlying type that is an integer, or any type of int, so think 8 to n64, or a float, or complex number, or string, it will take those as the underlying type of the generic can be one of these types. So if we use generic add, we can see that we can have a type of int 8, and we can add 1 and 2 together. We can also do string 1 and string 2, float 32s and float 64s. We can also do it implicitly without explicitly defining the type. So the top, I have the generic define, which is int 8, string, float 32, and float 64. And then at the bottom, Golang will derive the type based off the inputs, right? So yeah, Golang will do a little bit of help for us. I do, when it comes to generics, I do think that this is easier to read than just saying generic add, and then our variables. So that's just something that can help like read or make the your programmers easier to read the program itself, right? Now let's go into using equals. But before I go there, let me define a couple things here. So another type of generic that Go offers is called comparable. And comparable, what it will allow us to do is it will allow us to do equal signs and not equal. So here I have just equals, which is a generic function. It takes in an info string, and then it takes in two types of t, x and y. It will see if those x and y are equal to each other. It will output that value here as e. It will then output the info, and then it will output the type. And we can just use x because y is also a type of x. And then it will output the values for x and for y, right? So the thing with comparable is it's not like comp ordered. It does not allow operators such as plus signs or minus signs, which is something that is the difference between comparable and comp ordered in those types, right? Also, let's introduce what interfaces are. If you've ever used Golang, you should know what an interface is prior to generics being used as they were introduced. I'm not entirely sure, but I would say from its inception, right? Someone can correct me on that. But interfaces have been widely used within Golang, and the cool thing is, it wasn't until 118 that generics were used. And I don't really see the value of generics besides primitive types, such as using comp ordered or comparable. And the reason is because anything that mimics or implements a interface in Go has that same interface. So it isn't like Java or C# where you have to actually define the type that you're working with, that it extends or implements an interface. In Golang, everything that has area, the function or method area, and returns a float 64, implements the interface shape, right? So that's the important thing about Golang. It makes everything implement as long as it has the same method structure, right? The same method set. So here I'll introduce some structures. I'll introduce circle, I'll introduce square, and they both implement this interface shape, and they return this float 64 based off the area of the circle, right? And off the area of a square as well, right? So let's go back to our equals. So equals was a comparable generic, which takes in info, and then x and y is of that generic comparable, right? And then it just outputs some data. It tells us what x and y equal, which is really good. So let's just go through. I have a bunch of all these things that you can use comparable for to showcase basically an exhaustive list. I believe this is exhaustive of all the use cases for using comparable. So yeah, the first thing we can do is we can do booleans, and right here we can see that it's false, true and false are not equal to each other. We do integers, we get true, we get floats, those are false. And then the this and that, those are two different strings, so it's false, right? We get two complex numbers, those are both the same, so we get true. We can even do pointers with comparable. So that will be true because we have two of the same pair pointers. we can even do channels. This will be false if they're empty channels. And then we can add a value to our next channel. It'll still be false because the first one was as well. So this one will say false because they're different data. Well, I mean, it's not different data, it's just that they're different channels, right? And then if we say that C2 equals C1, so now they're both equal to each other, it will say true. So to be equivalent channels, they have to be the same channels. Now let's go to shapes. So we created our interface type, right? So what if we get two nil interfaces, A and B? If we did that, we should expect it to be true, and it is. Now if we create two implementations of those interfaces for circle and square, and we compare those values, we'll find out that it's also false because they're the different implementations and they have different values. But if we change B to circle radius 1.5, we'll find out that they do equal. So we get true. And then we can also do it by the circle, not by shape. So the actual structure, not the interface. And we can see if those values equal, and they do, right? We can change circle radius to 4, and it will say that they don't equal each other because the other radius is 4, which is 1.5, right? So 1.5 doesn't equal 4, so we get false. Unlike the previous one where they both were 1.5. We can even do this for arrays. And this is all using the same generic function, right? So if we take two arrays, they'll output, that have the same values. We can compare them, they'll equal true. If we change the value, then it'll equal false, because 1, 2, 3 does not equal all zeros. We can do the same thing with using the shapes as an array, and we get true because they're all equal. But if we change them, let's say 4, 4, and 1, then it'll say false, right? And then another thing that we can do is if we have a value of a non-interface type x and a value t of interface type t, can be compared if type x is comparable and x implements t. Basically what this means is x is a structure, it's a non-interface, t is an interface. We set t to a type x, and then we can compare those two with t. This is basically what we just did with the shapes when we did circles, right? So we had two circles, but we're comparing them as shapes. So if I introduce another type, let's call it y, and it takes a value called sum value, right? And let's say that's 10. Because they're different types, they're not going to be equal to each other, even though the structures are virtually the same. They only contain one property value or sum value, and it's also an integer, but they're completely different types from each other. So what we would expect here is x and t are the same values, so this would be true. The second one is going to be false, and then the third one will also be false. So let's go through that. We get true, we get false, and then we also get false. All right. So that's just showing equals and comparable, and how to use generics between all the comparable types, pretty much. Well, what about like if you're trying to create algorithms? So, assuming that you're creating algorithms, you probably want to use comp ordered. The reason why is because if you use the standard sort within Golang, comp ordered, you have to implement the less feature, right? And if you sort any values t, then your less function will have to return a boolean, and the only reasonable way to do that is with ordered functions, ordered types, because all ordered types give you the ability to use the greater than, less than operators. No other generic type will give that ability. So when you're trying to implement an algorithm, and you're going to do operations on those types with that generic value, you most likely want to use comparable or comp ordered. So that's what I'm showing here is a generic sort algorithm, and we're going to use this with integers, and then we're going to use it with floats, and then with strings. So let's see that happen. All right, so we sort the integers, and they all come out sorted, which is right. Now we can do sort, B32s. Float 32s, and those are all sorted. And the same thing with any of the strings that we have, right? So A through Z, which is good. Let's see what's next. I actually never did that. Now another thing that we have to introduce into generics is type constraints. Basically, a type constraint is anything that's an interface of a primitive type, or anything that's comparable. It helps to understand that there's something called underlying types as well. An underlying type takes a tilde. So if you look at ordered, all these values of ordered have a tilde associated with them. So basically this means as long as the type that you're dealing with has an underlying type of integer or any of these other types, right? String, int, float, doesn't matter. You can compare those values. So what is an underlying type, pretty much? Well, if we introduce these types here, we get that A1 equals a string, A2 equals A1, B1 equals a string, B2 equals B1. And these are just defining types, right? For A1 to A2 and B1 to B4. It's important to note that A1, A2, B1, and B2 all have the same underlying type of string. B3 and B4 all have the same underlying type for array string. And there's some more specifics on this on the go.dev, but I'll just read that, what underlying types are basically is this, what's a good example? Yes. So like if we create our own type and it's of type integer, this type integer should be an underlying type of type constraint int. That is the impetus of what an underlying type is. Now, what's a type constraint? Pretty much a type constraint is just an interface that takes in a type. So we saw that comp ordered is an interface, and it takes in all these types. That's the definition of a type constraint. You can't create a type of comp ordered because it has no defined type. All it's telling Golang is you can only use this type for a generic process, right? It's an interface. It will always be an interface. You can't instantiate an interface by itself. So you can just use it as a constraint to constrain your methods, your functions, your data structures, whatever you're trying to constrain. And so it allows the developer to create a paradigm to constrain the types that you're working with those algorithms or data structures, right? And another thing to note is with type constraints, you can also use a vertical bar to denote that it can be multiple types. So here we have type constraint int and string, which is an integer and a string. It can be either or one of these values. And we'll go into more detail about this. So let's say I have an adding interface and it has a type constraint of int. And then I have another one from adding type, and it has a type constraint of adding, right? So both of these interfaces, adding and from adding type. Then let me create a type other adding and integer struct, which is of type int. I know that might be kind of confusing. But if we create two methods here, generic adding type add and generic from adding type add, so that adding is of type constraint int, and then from adding type is of type constraint adding, right? We can tell Golang that we want to use any type int for these values, and it will type constrain it to those values of int, because that's the only type that's constraining adding, right? What it will not allow us to do is if we create let me go back down. Yeah. What it will not allow us to do is use type integer. So type integer is of type, not type integer. Yeah, it's of type int, right? So we can't use generic adding type add type integer for x and y because it's constrained to integer. Okay, the primitive type int. It's not using the underlying type int, so it's not using that tilde. So that creates a type constraint within our function. If you were to uncomment this code right here, it will come up with some errors. It will say pretty much the same thing. Does not satisfy adding, possibly missing, your tilde, or making it a underlying type integer, right? So that's what our issue would be right here. And then this one will say, yeah, it does not satisfy adding, which is of type int. Even though integer is of type int, it's constrained to integer, int, and not any underlying type of int, right? So that's one way that you can constrain your methods or your data structures, right? And I think that's pretty much all I wanted to talk about. Are there any questions? Yeah.
So I guess when I thought about generics, like, the two ways I was thinking about it are either like, think of it like reflection or think about it like code generation, right? Like, where does it land in your head? Like, when you're using, is it effectively just a code generator at this point? Or do you feel like it goes a little bit further with multiple types per interface kind of thing?
Is it code generation?
Like, could you do the same thing with code generation, I guess is the question.
You could do the same thing with code generation. I've seen that. I've used some code gen to do those capabilities, but then in that case now you have reproduced code, right? So the good thing about generics is you can write just one function, you can use that function, and it's pretty dry, so you're not, you don't have to use that code gen in that case.
Another question I had about, especially when you have an interface that supports multiple types at the same time for like an add function, like what order does the casting happen? Like if you're casting a float to an int to a float to an int, like is it like, do you have to worry about that, or does it never let you combine values that have ambiguity in how you cast like add?
Float to an int, a float to, what do you mean?
Like if you have an add function that takes any, any int-ish type thing, like an int float, int 3264, et cetera.
Yeah, any type.
And,
Okay.
But it can't take multiple types of the same function, right?
It can take multiple types of the same function?
Like, could you give it a float and an int the same parameters?
No.
Okay,
not-
kind of. So you don't have to worry about casting at least, right? It's always gonna be the same type.
So, yeah, let's go back to generic add. So right here, right? Generic add is, oh,
So X and Y could be the same type, but only, or could be different types, but only if they refer to the same primitive, right?
yeah, they have to be the same. They have to be the same type. So if I use something like 1.2, 1.4, and just 4, or I guess a string, right? Because it doesn't matter. Yeah. Because the generic is here. Because T has to be one type, can only be one type. That means X and Y have to be of type T. And it's going to return that type. So comp ordered guarantees that operation for adding or subtracting, that the two types that are being used for T, when used with those operators, plus signs or minus signs, subtraction or addition, it guarantees that the result is always going to be of type T, right? And you can't add a float to a string. Now, you could create a new method that takes a float, converts it to a string, and concatenates it, or, you know, I don't know, converts a string to a float somehow, right? But then it's not being generic anymore, right? In that instance.
Can you put another, I don't know what letter you would use, another T?
Another T? Yeah,
Can
so
you do
if
Y
I did,
another T?
yeah, if we did, let's say, K,
Sure.
and you use K here. Now it's gonna say that there's an error, mismatched types K and T.
Oh,
Okay.
Yeah. Yeah, so you can't, because you can't add a string to a float, right? So this will be it should be a compiler issue? Yeah, it is. Yeah.
But you could do other things with them.
Yeah, you can always do other things with them, yeah.
You can compare them since it's ordered.
Yeah, but it is ordered, yeah.
You can also do a type
Well,
switch.
you wouldn't be able to compare them either, right? Because they're not,
What if instead of comp ordered you use like int?
because they're not the same type, right? Mismatched types, yeah.
Could you do less than though? Because I know that.
Nah, it's not gonna work either way, right?
For less than string food.
Is it less than?
What you could do is do a type switch within a function, but then there's no different than using
Yeah.
this at that point.
Then it's an interface.
A type switch?
Yeah.
Or like a pointer
Well,
difference?
to assert if T is int and K is double,
Oh, yeah.
do
Yeah, yeah.
things, but then there's no different than interface at that point.
Yeah.
That's kind of, where I was going with
Then
it.
I actually run into a case that I had to do that because there was, I need to write a function, takes two underlying different libraries that they have exact same method, except they have a different return type. I need a generic input, I don't wanna have to write a wrapper, so I end up doing that way because I can do an interface T, which actually either one will accept, because I actually cannot declare my interface to be interface accept interface because the underlying type actually doesn't match. But interface of type T, either one will match, but within my generic function, I have to do a type switch to determine which one it is, and then do the action based on it.
Yeah, I've had to use type switches as well. When you're dealing with just some abstract type, right?
Yeah.
Yeah, that's useful in gen code too, generated code, type switches, or anything prior to 118. That would have been a big use case.
And I think when people say, why use generics,
on interfaces, that's when it makes the most use. So if you need some enforcement of relationship
Yeah,
between types
enforcement.
of
Type
multiple
constraints,
things,
right.
yeah. You're saying, I want there to be a relationship between this coming in and this going out, whatever.
Yeah, so using type constraints, or just an interface of a type, you can just force that value to be anything underlying or just that value itself. Yeah. I guess one quick, like to end, right? Yeah, the generic types in Golang are any comp ordered, and comparable. So if you're using generics, just remember those three, because mostly your algorithms will use one of those three. If you're using comparable, it would be like equal signs. If you're using ordered, then greater than, less than. You want to do operations plus and minus on them. And then any is like just if you're creating a collection and you need to input any type of value or structure, right?
Or we could have a slice T.
Slice T?
Yeah.
Yeah.
And then append to
Yeah,
it.
slice T,
Yeah.
right? Actually put that, I didn't talk about it, but yeah, we talked about the sorting list, right? Yeah, so you can do something like a sorting node where, well, yeah, you were saying slice T, right? Where's the sorting? What's down here? Yeah, like, so let's say we got sorted values of type B, right? So that would be a good case for any. But we're gonna compare it with, type K. How do we get type K? We have a get sort value, which takes the sorted value from our unsorted values, and does a for loop on all of them to get those K values, right? Whatever function that is, that's going to be used for our sort function, pretty much. If we can do that, right? So yeah, that's pretty much it. Thanks.
Can you do methods in those interfaces with the type constraints?
Methods for
Like
structures?
a normal interface where you say like,
Yeah.
there needs to be a function on this.
Yeah. So the method has a type constraint from the data from the structure, right?
No, sorry, can you?
So you're saying like you have some interface flurble, and you want to constrain to where you have a flurble going in and a flurble going out. Is that what you're saying?
No.
Okay.
I remember back in the day in Java, you would do interaction. You could I forget how to spell it, but you could do a thing where you'd say like, this structure needs to have these fields, not just methods, but like
Yeah.
No.
an interface is not that. It says these have to have the methods, but I don't care about the fields. This type constraint is sort of like I care about the fields again. Can you do I care about the fields?
So
and I
type
care about
constraints
the
are in interfaces. So the interfaces don't have fields.
It's spelled the same way though.
It's spelled the same way.
It says interface. Type foo interface.
Yeah.
Right,
So,
but you can't
but
put a
interfaces
method
in
in.
Go don't have fields or properties. Only structures do.
So just say
Structures
about
are
behavior,
implementation.
not data.
Or
You
you
can't
can't
say
the
I
arguments
need
of
to
the
have
type
this
constraint
methods
is-
within the interface.
Hmm?
The arguments of the method within the interface. Could
Yeah,
that
you
be?
can do that, yes.
Yes. Yeah, you can create the method for a defined interface can have generic properties. Or generic types.
Yeah.
Yeah.
You're saying think about the behavior. That's write the methods. But then a type constraint is think about the underlying type. I want to know if you can combine them.
Well, you can think about the underlying type, but you can't like talk about this structure has these fields. So you can't parameterize based on if these things have these fields, then they're equivalent. You have to just say if they are equivalent types. So you can't get more granular than tuple. And you can't
A type
methods.
constraint only has one internal type.
Yeah, so you should have to say it's a foo or a bar or a coop. You
Yeah.
can't say if my type has a dot X and your other type has a dot X.
Yeah.
then cool. So it's coarser. Yeah. And you can't, there's no polymorphic,
But could I say,
parametric stuff.
this is like an integer and has a method called foo?
Yes.
Can I do that in
Yes.
one
What,
interface?
can you require both? I'm not sure.
Can you require both? Like, okay, so X is a structure and implements foo, and what is the second requirement?
I think you're
So-
saying,
so-
sorry, go ahead.
You type the word interface, and it can mean two things. Type constraint or has methods.
You can do both.
You can do both. You can
But you
say
can't-
like,
Yes.
till the int.
So a type constraint is basically an interface. It's it's an interface that has a type, right? Let's say integer. And then you can give methods to that type
In the same interface.
in the same interface.
Okay.
Yeah, because it's still an interface.
Okay.
Does that make but you
Yeah.
oh wait, I might be wrong on that. I might be wrong.
I think you can, but it only applies derived base type. To say, for example, you say type integer to int, then you can define method on integer.
Yeah.
And then when you do interface tilde int, and then requires the method you define for integer, then you can no longer use int to supply for the constraint. You have to use the integer or any derived of your integer that with the method to satisfy that interface. Does that make sense?
Yeah, I think so.
Okay. Because you can't define a new method for a primitive types.
Right, but you could have a type which has an underlying type.
Right.
And a method on that.
Exactly.
And that would,
Right. That's the only time that would ever work. Because otherwise it just doesn't make sense that you constrain in type have this extra
Yeah.
custom method. It doesn't make sense. But if you have a custom type that is type in and then define method, then that's the only time that will make sense.
I would say probably if you run into that situation, it's probably a code smell.
Yeah, that's,
Yeah.
It would work, but why are you doing it?
That situation itself doesn't quite make sense.
You probably don't want to type constraint anything that's a non-primitive type in Go, because you have interfaces.
right.
Because if it already has an interface, a defined interface, right? You can just use the interface and not the type constraint for generic.
What if I want something that has a method that is comparable?
Yeah.
Is there an interface comparable?
Interface, comparable is an interface itself. So you can create a new type, you can create a new interface that is of type comparable, that has a type constraint comparable,
Okay.
and has a new method set.
Okay. Cool.
Well, then like the example you gave, like the shape has area, but if you say, I want to have the same type of shape go in and come out, then it would make sense to have shape be in your constraint in the generic rather than just be in your, because then you know that I can't have a circle going in and a square.
Yeah.
So again, it's a lot of the impetus of generics is to say, I want to maintain that invariant, but, you know, the types are the same on both ends. Or even like, I don't wanna pass in two different types of shapes, I always want the same kind of shape going in. Something like that.
You want to talk about short talk or demo or show and tell they want to do?
Are you Docker?
Sure. Cool. You okay with it being live streamed?
That's fine. Can I erase the board?
Oh yeah, go for it.
CI/CD, Kubernetes, a bunch of stuff in Go. Are you familiar with Docker? None? A little? Lots? Okay, cool. So we're gonna write a Docker file. We're gonna say from Golang. I'm sorry. I write it all caps. You'll understand it's lowercase, that's okay. We've Golang some version, and then because we want a small container, we're gonna call this one as builder. And we're gonna have another layer down here, we're doing multi-stage builds, and we're gonna say from distro list, which is a super tiny image that has the bare minimum of stuff that you need, and you can compile binary in it, and it works. Eventually, okay, so this is going to be the last part of our image, and that's what we're going to ship to production. So the way these work is every statement in the Docker file makes its own layer. It looks at the file system, sees changes, those changes get in the layer, we can cache the layers, we can do all that kind of stuff. Yeah, okay. So the normal way that you see recommended to do these builds, I should say, we use a mono repo. We have a bunch of services, and we also have like a libgolang, the common shared library stuff. And so when we're going to build just the one service, we're going to copy the library lib, and then just the service, we're going to build that one. And so the Docker files for each service are a little different.
Can you speak a little bit more about caching? What do you guys do
Yeah.
exactly?
Yeah, I'll get there, because the whole point of this is you're probably doing this wrong. because it's Golang and not Python or Node. Python or Node need to do this thing that I'm about to do. Golang does not, turns out. Okay, so what you should do is we need to copy like our lib to, lib. We don't care if it can be called the same inside the container. This copies from the outside of the container to the inside. And then, there's a Go mod, right? And there's a Go song. Yeah? And so you want to copy those, and then you download all your dependencies. Yeah? Pull down all the dependencies from the internet. You're good. Then we're going to copy the service. Then we're going to copy all the source code. Because the Go mod is the part that you need in order to download all the dependencies. Here's the caching thing. If we copy the source code first, and the source code changes, because we're building because the source code changed. Whenever one of these lines changes, it invalidates the cache for the rest of the file. So you don't want to copy the source code first, because that's probably changed. But the Go mod probably hasn't changed. A lot of source code changes without a Go mod.
I thought they had changed it a couple years ago that if a layer of cache was still valid, that it could be pulled in, assuming no changes in that layer.
What if it depends on the previous layer?
I think there's a way you can sort of have parallel paths, and then you combine them at the end.
Yeah.
I think you have to spell that, and I don't know how to.
Okay. No.
Is that a feature that you're talking about in Docker?
I think so.
You don't have.
I've never done it. Like no place I was cool enough to do multi-stage, and so.
Yeah, it's because I'm on the infrastructure team and I hate giant Docker images.
So I do too. Like the way that I explain it to people is I've done it long enough that there was the question of whether we would have fat containers and what that meant, and they're like, "What does that mean?" It's like I can't talk to you. But I did have another question for you. Why distroless instead of Scratch?
You need TLS certificates, and you need. There's something else that distroless has in it. It's TLS certs, and it's like like time zone data or something. It's
TV.
like really low level, and you get weird stuff if you don't have that. You can do it from scratch.
Yeah.
That probably works.
Do you not even get something like out of Alpine, like a busy box?
Yeah.
Okay.
This doesn't have a shell.
Oh. Mm.
No engineer is capable of, kubectl execing into this container to run shell commands because there's no shell.
Unless you get a clever motherfucker, because you can't add it in afterwards.
Yeah, but they have to edit the Docker file, and I'm a code owner.
No. You can inject a shell into a running Docker container.
Like Bash?
Yeah. I mean, I wouldn't choose Bash, 'cause that's a lot, but yes.
Just copy it.
Like,
It's fine.
oh, copy the files in. Yeah. The file system's read only.
Okay.
Yeah. And you're not root.
Is there a slash div?
Probably. Yeah, I mean, there's ways. But part of this is like small containers, and part of this is like, I'm sorry, you can't run shell commands in there. You have to do like normal engineering process, like with pull requests and stuff.
Do you have a different, image inside of distro list for testing?
Yeah. So dev environments run also in Docker containers, and they don't use distros. So actually above this line, there's a from Golang as development, and that's what we build. And that's a full fat container, and it's got a shell, and it's got all the things you need. We install Delve, and we install curl, and we all this stuff so that you can do development. But everywhere else, it's this distros.
What's your CI/CD infrastructure, and how the caching works? Is it like GitHub CI or
Yeah,
GitHub Actions?
GitHub Actions. Yeah. So on the Docker command line, we pass a bunch of flags to say like we're gonna cache to a place and a cache from a place, and so there's like a lot of layer caching that happens going here. But this actually, the testing to do this, I was doing like Docker build no cache. So the cache is, if it's there, great. If it's not, I want it to be faster anyway. And this sped up the no cache version, so cache is even better. Okay, so you copy the Go mod, you copy the Go sum, you download all your modules. Now we copy the library. Next, we copy the service Go mod. Yeah, you understand? And we do Go mod download again. And that's to down, because the service may have additional dependencies on top of the standard, our library stuff. Yep. Now we compile. There's more than one binary in this image. The same image, the image is used for the service, but it's also used for like cron jobs for the service. And so we got to compile several binaries. Go build. Blah blah blah. The main thing, and then another one for that other binary. Finally, down here, we copy, we're go build -o, some path, blah, blah, and we're going to copy the binary. We're going to copy from the builder stage. So that's this thing that we compiled. Yep. This is how all the tutorials, most of the tutorials online will say like, this is how you do a build. Because this is how you do a build with Node and Python, and this is like a good idea. You copy the package JSON, and then you download all the whole internet, one black hole, and then you copy all your source code, and then yeah. But turns out this is slow. 20 to 30%. It's much better if you just drop all this nonsense about like, let's have a bunch of layers and let's copy stuff together. Let's just copy the library, copy the, I forgot to copy the service, and compile it. And it's like 20% faster. I'm looking at the PR where I implemented this. Yeah.
Are you saying, yeah, so one thing that we did was we had a separate image where we placed the Go mod install, or go get all-in-one image, and then our builder image would use that image, copy the library, run the builds.
Yep.
And then place them in our distro lists.
I bet it's slower.
That would be slower than what you're introducing?
Yeah. There's basically two ways to make things go faster. There's do less work and do work in parallel. And I think, don't understand why this is faster. I think what's happening is the compiler is doing stuff in parallel. I think as the compiler is walking the source tree, it's saying, oh, I gotta go get a dependency. Let me go get that dependency and compile it. And it's walking to the next bit of your source code, the next package. This package doesn't have any external dependencies, or I've already downloaded them. I'll compile that now. I think it's doing a whole bunch more in parallel, both downloading source code and compiling packages, and it makes it faster. In our big service was 23% faster. One of our small services was 58% faster. Now, there's not a lot of seconds. I'm talking about 120 down to 50 seconds. But I do this on every, we have preview environments. I gotta do this on every preview environment, even if they didn't change this thing. I gotta do this in dev all the time. I gotta do this for every deploy of that service to production. Not only is it faster, it's fewer steps, it's easier to reason about, it's easier to read. Do you know Docker? No, this makes sense. The whole weird copy, partial bits of stuff, and go mod download, but you haven't got it all yet, and we actually had 2 go mod downloads in here. Copy the thing, compile it, done. It's faster.
How do you
How do you get past not downloading your dependencies? Because you need it.
Oh, that's the other thing.
The build does it?
NPM
Oh, it
has
does?
this like NPM install, and then there's like a compile thing. Go build, downloads your dependencies for you.
So, have you tried to do a Go mod vendor
Even the Go run,
before you enter the Docker, and then
Yes.
have that?
Okay.
How does that compare? Because we had never had to deal with
it's
that
a nice,
because of a SSH key private repo problem. So
Yep.
we actually get around using the vendor, effect we call a fake vendor, and then go enter into Docker to do the build. But in terms of the speed, have you tested what's faster?
I still think it would be slower because the compiler can't be compiling while it's downloading.
Right, but if you vendor it first, you don't.
Yeah, I'm saying that the reason this is
okay,
faster
I
is
see
because
what-
this
okay.
is doing download and
Interesting.
compile at the same time. I think, I don't know.
That
Whereas
makes
if you
sense.
split it, if you did a vendor before, you gotta wait on whichever is the slowest HTTP server out there to get your module.
Hmm.
And you're gonna do a bunch of stuff in parallel still, but you're gonna spend time waiting for it, and then it's gonna come down. Then you're gonna have a copy step, right?
Yeah.
A whole bunch of files load into the Docker image, then you're gonna have a compile. But I think part of the thing is this does a download at the right time. So, anyway.
So how do you work around? Do you have to deal with private repo? Private GitHub repo?
Nope.
Okay.
It's all in a mono repo. So we don't have to,
Okay.
we don't have to auth to,
You don't have to worry about the not having SSH credential access in private repo. Okay.
now I will say there's one way I think you could make it faster, and that's compiling outside the Docker container. If your Docker file said copy the binary into the container, then you get to cache the precompiled, I don't even think they are .sos, but whatever, the precompiled packages, you could cache those outside of the Docker container. That would definitely be faster. But I'm also not sure, like I'm thinking about, somebody said something about hermetically sealed, and doing it in a Docker container because of like reliability, repeatability, and I know exactly what the dependencies are, and I know.
Yeah, it could not, maybe it could become not reproducible.
Right. Even though it's Go, Go's really nice then. Anyway, try it out. I bet this is faster.
Yeah, very cool.
I figured I'd share a couple of our dumb CI tricks that we've had to use over the years to make things suck less. We compile lots of Go,
So, for example, our cross-compile build of our agent effectively does like 32 different combinations of OS and architecture. So it generates a 12 gigabyte Go cache, which immediately evicts the entire GitHub CI cache, because it's got a 10 gig limit. So we can't benefit at all from any of the caching in GitHub CI. So we just don't even use the cache anymore on GitHub because we blow it out every time we build, and there's no way around it. So thinking a little bit less insane version of that, one thing I do love about Go, and what you mentioned here before, is that because Go will, you don't need a separate Go mod download stage, and it'll scan all the code dependencies and start compiling as it's building it, and also look at the object cache to skip one of the ones that are already built. So theoretically, like, it's doing concurrency. And the great thing about that is if you have lots of cores in your builder, it'll use all those cores to compile your code. If you've got a massive freaking Go project, like, we build our console binaries with 32 cores. Because why the hell not? Like, we save so much time. Like, we probably do maybe, I don't know, 20 builds a day. We still pay about $200 a month for the CI actions. So it's not that expensive to use the larger GitHub runners, because the default ones they give you are so crap. Like, you run the disk I/O limits, like, you can download faster than you can write to disk on the lowest 2-core GitHub runner. So just keep in mind, like, you can just scale that thing up to 32 cores, and it'll actually complete so much faster with a Go-based build, because Go is really good at using all your CPU, your cores, right? So first thing I recommend to folks, if you have really slow builds, just use 32-core builder.
Is this the public GitHub hosted, not self-hosted? Right?
Yeah, you can run. We have a couple self-hosted ones too. The problem with those is, like, if you ever have that machine backdoored, like, we're doing these giant, 12 gig object caches. We're like, oh, we'll just run on a self-hosted builder, and it's great, except for if we ever pull in a poison build and our PR has a backdoor or whatever dependency, now our object cache is poisoned until we roll it out again, in which case we don't save any. So from a security perspective, we don't really get a lot of benefit from it, unfortunately. So we stopped using it in that sense, and we just wait a little bit longer and use more cores. So the first thing we figured out is, like, just use more cores and save yourself some pain. Another one, of course, is if you want to save some money, make sure that you've got concurrency groups set up in your CI builder, so you always cancel the build in progress when you start another one, because otherwise you're paying for it twice. So especially when you start cranking up how many cores you're using, you don't want to start spending money out the door, right? Some other fun tricks here, of course, check out all the Gfetch stuff once, so that you're pulling your repo down. And this is the one that I think a lot of folks don't really know about. Is if you're calling action setup Go, even like the name version, it won't actually give you the latest version by default. So normally you have to have a Go version built in here. You put like Go 1.2 creation like that. We don't like doing that because it sucks. So what we do instead is we actually modify the Go mod file in our root of our repo with all of our workspaces below it to have our Go, whatever Go version we're targeting at the time of 1.2.3, 1.2.3.2. And you use the GitHub action to refer to your Go version file directly, and then it always grabs exactly that version for your build. And it saves you a couple steps and makes it a lot faster. What you also have to do is, because the Go action isn't very smart sometimes, they often, if there's a security release for Go that often has like one of the Tuesday at 2 p.m. or something like that, there won't actually be a new version of the Go action package that knows about that build as the default version for a couple hours. So what you do instead is you say check latest true, cache false. That means always grab that version no matter what, even if the default action doesn't know about off by default. So if you're trying to do a security build to fix like a new security bug that's in the Go stack, like the 1.2.3.2 bug, for example, you need to use check latest true, cache false, otherwise you're going to get a stateless version of the build, even though you built it after the fact that the patch was released. So this is something you kept fighting us. We're like, okay, we built it, why do we still have this buggy version of Go? Oh, right, because the freaking Go action is stale. And so this is one way to get around that.
Does your Go mod say half the patch version?
Yeah, so our Go mod will explicitly say 1.2.3.2.
Okay.
And so we just update mainline the second it's released, we bump everything internally and go for it. The only time we wait is when there's new minor release, like 1.2.2 to 1.2.3. We typically wait for the first point release to shift our code over, and then we stay on the pre-racing.
Oh, you're saying even though it says 123.2,
the Go builder
action might get 1.
Yeah, if you call setup Go, you might get .1 because if the Go builder the action doesn't know that yet. So you have to do the check latest true and cache false to say ignore whatever your default is, give me exactly the version that's patched. Otherwise, you'll get the stale version for about 6 hours because it's going to lag behind a little bit. So that one did us like 3 times and finally we're like, okay, there's a workaround, fine, let's share it with the world. But something else that's interesting, when you build a Go cache, typically you have a single Go cache key. So you'll say, I want to cache, let's see, go further here. You'll say like my cache key is be runner OS, like Linux-go console hash file start at go.sum, which means for this exact source code, create a cache key based on that. But the actions cache is really smart. You can actually tell it to use incremental levels of freshness of cache keys to restore. So if we don't have this exact Go console dash hash sum available, we never built this version of our code before, we fall back and say, okay, did we build anything with Go console before? Is there anything in the cache of Go console? Even if it's just one row behind. And you want that because a lot of object files have changed. A lot of your dependencies haven't recompiled yet. So you change your source code, you don't change your dependencies, you actually get to keep most of your object cache in your cache that way. And you further down and say, wait, well, if we don't have anything in the Go console, just grab whatever our most recent Go build was entirely. Like, we have a bunch of other CIs that build Go-based things. So even if we haven't built, like, for example, that specific Go console that day, we might have built, like, one of our other utilities, use a lot of the same libraries, so we still get benefit from that cache by falling through to the next level of cache. So it makes a lot of sense to build out these kind of multi-level restore keys in your caching infrastructure, because you basically can benefit from separate jobs than the ones you're building for. So if you're building like 5 services, but they all basically share the same dependency, like even if you don't have that exact cache available, go grab a related cache by falling down the tree, and you can get a lot of benefit at your speed.
I'm sorry. What is the difference between this cache versus the 10 gig cache limit that you were talking about earlier?
These all apply to 10 gig cache limit. The second you go over 10 gigs in GitHub, it says screw you, we're throwing away.
Gotcha.
So you can get to about 11 gigs, but then your next checkout won't be able to retrieve it. And often if you're using a 2-core runner, it doesn't really matter because downloading your 11 gig cache will take you so long, it's actually slower to download your cache than rebuild it half the time because the runners are so slow. So if you're running on a lower CI or lower, like a default GitHub runner, for example, and you have a really big cache, you may be faster not having a cache just because they crank down your I/O so low on those nodes.
Out of curiosity, how many dependencies do you have to reach like 10 gigs? That seems like a lot.
It's not that we have a lot of dependencies in one code base. We probably have like 100 or something. It's not terrible. Well, the big ones for us are like AWS SDK, Azure SDK, all that stuff. So each one of those is like 7 megs compiled. It's just a lot of crap, right? But we cross-compile across 32 OSs and cores, or architectures. And we also built ARM6, ARM6L, ARMv4, ARMv5, ARM64. Then for FreeBSD, OpenBSD, NetBSD, Linux, like, you know. So we build everything. Our major is massive. And so each one of those builds is only about 100 meg binary. But we're building like, it's about 2 gigs of compiled binaries when we're all set down with it, but has about an 11 gig cache of object files behind it for all different parts.
Okay.
Thank you, Seth.
Doesn't SetupGo do this cache?
SetupGo does the cache, but you have to tell it to be smart about the cache hierarchy. Sorry, SetupGo doesn't do it directly, you have to do your own, we do it here.
I thought it could pass the.
Oh, we turn the SetupGo cache off and we do our own cache below it. So we use the cache action instead of the Go cache because we're smarter about it. And that we have like multiple levels. Otherwise, Go cache will just use the top level cache. And that's not great when you have lots of concurrent builds and there are various freshnesses. So that's about it. We just do a lot of really dumb things with our builds here. And of course, like our normal internal security rules, if we're referencing an action that doesn't start with the word GitHub, then of course we pin the SHA hash no matter what. The reason for doing that, for anyone who cares, is that if you have a tag on it, for example, like v4, v5, you can replace the tag. Someone can just like backdoor push v4 back up again, and now your Boral's actions-r v4 points to a backdoor version. But if you pin it to a specific SHA hit commit, then you're all going to grab just that one commit hash no matter what. So our trade-off is like, if it's a GitHub Actions CI, we just use our actions correctly because hopefully they haven't been hacked. And if they do, the world has bigger problems than us. But if this guy named Morales gets hacked, like we don't want to have to worry about that. We want to pin it to a particular SHA hash. So that's kind of our trade-off in that way too. That way, but yeah, we spend way too much time fighting with GitHub CI. So it sounds like you still get a different approach on the Docker side. We just build everything basically raw on binaries. But yeah, cool. That's it. Thank you. Did anyone else who just arrived or arrived a little later need parking validation? Anyone else have any small things you want to talk about or share or discuss or anything like that? Cool, awesome.
I mean, I would like to share something, but it's not really Go related. So I'm kind of like what's it called? Well, I've never really coded with Go before. Once back.
Welcome, one of us, one of us.
I was going to use Go and like the advent of code back in 2022, but I ended up using Scala. I'm sorry. But I like it. I like it. Yeah. So basically, just to be quick, because this isn't really related to this meetup. Hi, my name is Gonçalo. I'm from Portugal, and I've been in Austin for a week. I'm flying back home on December 2nd, and actually I'm looking for opportunities in tech. I have a master's in software engineering from Portugal, and I do mainly full stack. I've never coded with Go, but I'm going like to all these meetups and meeting new people. So thank you for sharing your.
Thanks, welcome.
Yeah. Thanks for sharing your stuff. I got most of it, you know. I got most of it because I went through the Go documentation, but I haven't really coded it. You know? But yeah, I'd love to connect if you're interested in having a junior developer from Portugal. And that's it. So thank you for your time. Thank you for listening to me.
Not to be rude, but what is the tech scene like in Portugal? No jobs? What is?
Sure. Yeah. We can talk about that. And if you want to talk about tourism in Portugal, it's great for foreigners and digital nomads. It's just not really good for locals, you know. The tech scene, I mean, you can get a job there, but things are really expensive, and the tax system is really complex, and it does not favor locals at all. So there's a flat tax for digital nomads of 15%, and when I got out of college, I was getting paid about 1,600 euros a month, which is slightly above the median national salary, by the way. So just slightly above, and I'm not complaining. But I'm just saying that with the housing crisis going on in Europe, it is not easy. About 60% of my friends from college, from my graduation year, have relocated to somewhere else. So Portugal's major export, besides cork and wine and some cheese and some other stuff and some honey, yeah, codfish also. It's qualified labor, and that's why I'm here mostly. So yeah, I just went the extra mile of going overseas while my friends stayed in Europe. Yeah, so that's it. If you want to talk about Portugal, and if you're interested in visiting, it's great. Like sunny weather, pretty cheap.
You get a job with the tourist office in Portugal.
I mean, I love tech too much to become a tour guide, but who knows? That might be my future.
Is it just like Lisbon and Porto and the big cities?
I'm from the north. I live in Porto. If you know where Portugal is at, it is not part of Spain, by the way. By the way, it is not part of Spain. It's a different country.
Is Porto as bad as Lisbon with the nomads and the tourists and not housing? And stuff?
No, Lisbon is way worse, but for sure, Porto is not far off. It's great, for sure. I mean, I go downtown and I don't even hear Portuguese anymore. I hear mostly Brazilian. Okay, so
Brazilian Portuguese.
Yeah, Brazilian Portuguese, but it's like it's not Portuguese. There's Indian shops everywhere. There's a lot of human trafficking going around. Yeah, like there's a huge housing crisis. Like I said, the median salary in Portugal is about 1,400 euros a month, and rent for a one-bedroom apartment in town is like 1,000, like 1,100, 1,200. So most of your salary goes to rent. So like, yeah, I could either move away from the city, which I want to anyway, but yeah, I decided to go on this adventure. Yeah, so thanks for listening to me, and sorry, I've already taken up so much time.
Alright, well, at least you came for ACL, right?
For what?
Did you go to the ACL concert?
No, I didn't.
Well, you're already here, right?
So, I live in a town called Leander, which is a suburb of.
I know.
So we have a little Reddit meetup that we do once a week, and the person organizing it is from Portugal, from Madeira.
Oh,
So
right,
if you don't have anything to do on Thursday or Friday night, they have it set up.
No, I have all the time.
Okay,
Well,
well, check
because
check the Leander subreddit, she usually updates it like the day before or something, so
Okay,
it'll probably
cool.
be anytime now.
Yeah,
We
I
usually
mean-
just go to a bar somewhere around the area.
Yeah, I'm here in Austin till the end of the month, then I'll go to Dallas for another month, then I'll fly back home.
Cool.
Well, this weekend's now the second weekend of ACL, you can get a ticket last minute for like $100
I know,
$100.
I've been thinking about that, we'll see. We'll see if my budget can handle it.
Definitely don't buy it online, like Ticketmaster will add like $300 to the bill for no good reason, but if you just go to like the will call, they'll sell you a ticket at like, you know, super cheap day price. Like, I just walked down there Sunday at like noon, like, what do you got for like $100? Like, we'll give you this 150. Like, sold. Alright. So you can definitely get a better rate at the door if you need to. Plus you have all the people hawking wristbands and stuff like that. So.
Oh, and is this being recorded?
Probably, yeah.
Okay, so it's for the TSA agents listening. I am not legally, I know that I am not legally allowed to work in the US, but I am legally allowed to look for work. No, I had some issues with TSA when I landed here. They were super suspicious.
Well, that's what they do.
Yeah.
A friend of mine was traveling to work for meetings only, not working here, and he still got stuck in Dallas in the jail there for 2 days at a time each time. And the third time he came to the U.S. in like 5 years, like, I'm done. I'm tired of going to jail just to come to see my coworkers. They would just harass him, put him in a holding cell overnight. He's like, dude, I'm just coming here for a meeting. Like, what the hell? No, we think you're working. I'm like, definitely not working in the cell. Like, no, it was tough. He's back in. Yeah, they're pretty vicious.
So there's a Leander subreddit.
Yeah, surprisingly enough. Yeah.
I'll look
There's a
that.
subreddit for everything.
Yep.
There's
No,
a-
yeah, like I think about half a year ago, she just started posting. She says, "Hey, we're gonna have social media. Just show up." And we usually have half a dozen to a dozen people.
I'll look it up because I had a meetup for Leander, but I didn't go there because it was kind of far